Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and today we gonna present our report, and my name is IZHAM bin Ibrahim. Matrix number AE210046. Okay, so for the introduction, frequency response of BJT FET amplifier is a frequency range area of the amplifier operation in an amplifier made by frequencies capacitor that is coupling and bypass. In the connection appear as short circuit to alternate current AC, which is also considered the capacitor negligible. Frequency response are used to illustrate the change in gain and phase over a certain range of input signal frequency. In this group project, we will analyze BJT FET amplifier, low and high frequency response. So this is the diagram of the frequency response curve of an amplifier. Follow frequency response, capacitor will affect the gain and phase shift of amplifier signal. The reactance is greater and becomes significant. Hence, voltage gain is lower because voltage signal is dropped across coupling capacitor, while the effect of internal transistor capacitors can be ignored by leaving them open. For high frequency response, reactance Hc is lower and become negligible, and we can treat this capacitor as short circuit, while effect of internal transistor capacitor is significantly large and its effect need to be considered. So this is the circuit given in our question. So the network in figure 1 has following specification: IDSS equal to 8 milliampere, gain AV equal to -4, CGD 2 PF, CGS 4 picofarad, CDS equal to 0.5 picofarad, CWO 8 picofarad, CWI equal to 6 picofarad. Assume the output of resistance RD is equal to infinity. So for question A, determine the transconductance GM and GM0. Support your answer with the aid of diagram and use graph paper to find Q point. So this is the calculation. This is the formula to find GM, which is 2IDSS over VP times 1 minus VGSQ over VP squared. Also, we just need to input the value inside the formula to get the answer for GM. When VGS equal to 0, GM is equal to GM0 equal to 2IDSS over VP. Thus, this equation and this equation, we can get that GM is equal to GM0 times ID square root ID over IDSS. So we just bring the GM0 to the left side and input all the value which with the information given, and we get GM0 is equal to 15.37 millisecond. So this is the graph to find Q point, which is this line is the line of IDSS and VP, and this line is line ID. The intersection between these two lines is where is the Q point, which is at here. So now I will pass it to our next presenter.
Hi and Assalamualaikum. My name is Rashid bin Rasul. My matric number is DE2053. So I'm here to explain about the analysis and solution for question B. So this is the question that I've been given, and then the question B is calculate the high cutoff frequency FHI and FHO and determine the dominant high cutoff frequency. So as question given that IDS equal to 8 MA, gain for the gain -4, CGD 2 PF, and CGS for PF, CDS 0.5 PF, CW0 at PF, and CW1 is 6 PF. So you need to transform the circuit into this form first, and then we determine the RSIG. This is from the calculation from the question A that my friend have been before. So first we need to calculate the pole frequency. So the formula is 1 over 2 pi C1 times RG plus RSIG. So after we took the formula and then key in all the value, the answer is 0.01561. And then next is second pole is, for the formula is a bit different. 1 over 2 pi CS times 1 over GM parallel to RS, and then we input the value and then we get the answer 159.154 Hertz. And then for the pole frequency, and then for the formula is 1 over 2 pi C2 times RD plus RL, and then for the pole frequency we get 1.989 Hertz. So for the lowest frequency, FL is equal to highest pole frequency for minimize the total capacitance. So FL equal to F2 equal 159.154 megahertz. So that's all for the question B.
For question C, calculate the low cut-off frequency for each of the coupling, CG, CC, and bypass CS capacitor, and identify the dominant cut-off frequency. First, we construct a equivalent circuit, and then we start calculate the lower cut-off frequency, FL. And for CG, we use the formula 1 over 2 pi RSIG plus RTH CG, and substitute the value inside the formula, we get 1.49 Hz. For CS, we use the formula 1 over 2 pi RS over 1 GM CS. Substitute the value inside the formula, we get 568.3 Hz. For CC, we use the formula 1 over 2 pi RD plus RL CC. Substitute the value inside the formula, we get 21.65 Hz. The highest frequency among CG, CS, and CC is the dominant. Thus, the dominant cut-off frequency is 568.3 Hz. Importance of analog electronics. First is it is vital for many different areas and essential to power design, OM, circuit, and filter. Physical process work along a continuous spectrum and have no discrete units, just like digital signals. Therefore, analog electronics are indispensable whenever digital electronics interact with the real world. Some of the example is loudspeaker, landline telephone, audio tape, analog voltmeter, analog wattmeter, ambulance siren, and analog clock.
So I'm back for the conclusion. So based on our report and study for this project, our group made conclusion that from this project, a student will be able to analyze the circuit given and make a calculation based on topic that have been studied. The circuit is involved based on diode and transistor presented based on prototype electronic circuit. By the research, electronic circuit is very important in current world. This is due to expense of the current technology based on semiconductor in every electronic device that we have been used in our daily life. Thank you and That's all from our group. Thank you and Assalamualaikum.